The inspection failure concerning the overhead service likely stems from a misapplication of Type SE service entrance cable within a rigid conduit mast. The inspector's citation is rooted in the National Electrical Code, specifically Section 338.10b, which governs the installation of Type SE cable. This section clearly stipulates the permissible raceways for Type SE cable. Type SE cable shall not be installed in a raceway unless the raceway is a rigid metal conduit Type MI, Schedule 80 PVC conduit, or Schedule 80 RTRC conduit. The core issue is that standard Type SE cable possesses a non-metallic jacket. This jacket, while suitable for many applications, is not inherently resistant to physical abuse, especially the kind that can occur when pulling the cable through a raceway. The act of pulling the cable can abrade, tear, or otherwise compromise the jacket, leading to premature failure and potential safety hazards. The approved raceway types, namely rigid metal conduit Type MI, Schedule 80 PVC conduit, and Schedule 80 RTRC conduit, offer a robust layer of protection against such physical damage. These conduits are designed to withstand significant impact, crushing forces, and abrasion, thereby safeguarding the Type SE cable within. Consider the properties of each approved conduit type. Rigid metal conduit, often steel or aluminum, provides exceptional mechanical strength and is suitable for both indoor and outdoor applications. Its inherent rigidity prevents deformation and protects the cable from physical damage. Type MI, mineral insulated cable, is unique. Schedule 80 PVC conduit, characterized by its thicker walls compared to Schedule 40 PVC, offers enhanced impact resistance and is suitable for direct burial applications. It is also resistant to corrosion, making it a good choice for damp or corrosive environments. Schedule 80 RTRC conduit, reinforced thermosetting resin conduit, provides a balance of strength, corrosion resistance, and ease of installation. It is lighter than metal conduit but still offers significant protection. The reason for the specific allowance of Schedule 80 PVC and RTRC conduit as opposed to their Schedule 40 counterparts lies in their increased wall thickness. This greater thickness translates to superior impact resistance, ensuring that the conduit can withstand the stresses associated with cable pulling and external forces. Now I'll address the specific violation. The installation of Type SE cable inside the standard rigid conduit mast, which was then screwed directly into the meter base, contravenes the NEC because the rigid conduit itself does not inherently provide the level of protection required for Type SE cable unless the cable is specifically listed for use in that manner. While rigid conduit offers mechanical protection, the NEC mandates specific raceway types to ensure adequate protection in conjunction with Type SE cable's inherent limitations. The proper course of action involves removing the Type SE cable from the rigid conduit mast. Instead, consider installing the cable as a service lateral following the guidelines outlined in Section 230.42 of the NEC. This section dictates the allowable ampacity of service entrance conductors based on the size of the service and the type of conductors used. Section 230.42 focuses on the sizing and protection of service entrance conductors, ensuring they can safely carry the intended load. This involves calculating the demand load of the building or structure being served and selecting conductors with an ampacity equal to or greater than the calculated load. Furthermore, Section 230.42 addresses the protection of service entrance conductors against overcurrent. This typically involves the use of fuses or circuit breakers sized appropriately to protect the conductors from overheating or damage due to excessive current flow. Other considerations when installing a service lateral include burial depth, protection from physical damage, and proper termination at both the service point and the building or structure being served. The NEC provides detailed requirements for each of these aspects, ensuring a safe and reliable electrical connection. Now consider the implications of the UL listing. The UL listing of Type SE cable defines the specific conditions under which the cable has been tested and found to be safe for use. Installing the cable in a manner that deviates from its UL listing voids the warranty and potentially compromises its safety. The UL listing is a crucial aspect of electrical safety. It signifies that a product has undergone rigorous testing by Underwriters Laboratories, a nationally recognized testing laboratory, and has met specific safety standards. These standards cover a wide range of factors, including fire resistance, electrical insulation, and mechanical strength. When a product is UL listed, it bears the UL mark, which serves as a visual indication of its compliance with safety standards. Electrical inspectors rely heavily on UL listings to ensure that electrical installations are safe and code compliant. Using UL-listed products helps to minimize the risk of electrical hazards such as fires and shocks. The listing provides assurance that the product has been evaluated for its intended use and meets the necessary safety requirements. In the context of Type SE cable, the UL listing specifies the allowable installation methods, conductor types, and environmental conditions for the cable. Installing Type SE cable in a manner that deviates from its UL listing can compromise its safety and void the manufacturer's warranty. Moreover, it may also violate local electrical codes, leading to inspection failures and potential fines. For instance, the UL listing might specify the minimum bending radius for the cable, the maximum operating temperature, or the types of connectors that can be used with it. Adhering to these specifications is crucial for ensuring the cable's safe and reliable operation. In summary, the inspection failure highlights the importance of adhering to both the NEC and the UL listing of electrical products. Understanding the limitations of Type SE cable and the requirements for its proper installation is essential for ensuring a safe and code-compliant electrical system. The use of rigid conduit as a mast, directly screwed into the meter base with SE cable inside, presents several potential issues. The first issue is physical damage. While rigid conduit offers some protection, pulling SE cable through it can still damage the cable's outer jacket, especially if the conduit has sharp edges or burrs. The second is heat buildup. Enclosing SE cable in a conduit can restrict its ability to dissipate heat, potentially leading to overheating and premature failure. The third is moisture accumulation. Condensation can form inside the conduit, potentially corroding the cable's conductors and insulation. The fourth is code violation. As previously mentioned, NEC Section 338.10b restricts the use of SE cable in certain raceways. The NEC is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years by the National Fire Protection Association (NFPA) and is widely adopted by state and local jurisdictions in the United States. The NEC covers a wide range of topics including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for electricians, electrical contractors, and electrical inspectors to be familiar with the NEC to ensure that electrical installations are safe and code compliant. The NEC is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. Chapter 1 covers general requirements such as definitions, wiring planning, and examination of equipment. Chapters 2 through 7 cover specific wiring methods, equipment, and occupancies. Chapter 8 covers communications systems such as telephone and data networks. Chapter 9 contains tables and examples for calculating electrical loads and conductor sizes. The NEC is a complex and detailed document, but it is essential for ensuring electrical safety. By following the requirements of the NEC, electrical professionals can minimize the risk of electrical hazards and protect people and property from harm. To ensure compliance with the NEC, it is crucial to stay up to date with the latest edition of the code and to consult with qualified electrical professionals when planning or performing electrical work. Failure to comply with the NEC can result in fines, penalties, and even legal liability. In addition to the NEC, local jurisdictions may also have their own electrical codes and regulations. These local codes may be more stringent than the NEC in some areas. It is essential to be familiar with both the NEC and any local electrical codes that apply to the specific location where electrical work is being performed. The electrical inspections are an important part of ensuring code compliance. Electrical inspectors are responsible for verifying that electrical installations meet the requirements of the NEC and local electrical codes. They typically conduct inspections at various stages of the construction process, including rough-in, final, and special inspections. During an electrical inspection, the inspector will examine the wiring, equipment, and grounding system to ensure that they are installed correctly and safely. They may also perform tests to verify the integrity of the electrical system. If the inspector finds any violations of the NEC or local electrical codes, they will issue a notice of violation, which must be corrected before the electrical system can be approved. Ignoring such notices can lead to further penalties and delays in the construction process. When working with electrical systems, safety should always be the top priority. Electricity can be dangerous, and even a small mistake can have serious consequences. It is essential to follow all safety precautions when working with electrical wiring and equipment. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, and using insulated tools. It is also important to energize the circuit before working on any electrical wiring or equipment. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Before de-energizing a circuit, it is important to test it to ensure that it is actually dead. This can be done using a voltage tester. If the voltage tester indicates that the circuit is still energized, do not proceed with the work. Instead, consult with a qualified electrician to determine the cause of the problem and to safely de-energize the circuit. Another important safety precaution is to never work on electrical systems in wet or damp conditions. Water is a good conductor of electricity, and working in wet conditions can significantly increase the risk of electric shock. If it is necessary to work on electrical systems in wet conditions, take extra precautions to protect yourself from electric shock. This may include wearing rubber boots and gloves and using a ground fault circuit interrupter (GFCI) to protect the circuit. By following these safety precautions, you can minimize the risk of electrical hazards and ensure that you and those around you are safe. Remember, when in doubt, consult with a qualified electrician. Electrical work should only be performed by those who are properly trained and experienced. Attempting to perform electrical work without the necessary knowledge and skills can be dangerous and can lead to serious injury or even death. In summary, the inspection failure related to the overhead service highlights the importance of understanding and adhering to both the NEC and the UL listing of electrical products. By following the requirements of these standards, you can ensure that your electrical installations are safe, code compliant, and reliable.